Introduction. There are experiments the world wasn't meant to hear about, quiet projects buried in labs, intelligence files, and forgotten research sites. Moments where reality didn't behave the way it should. And the evidence couldn't be ignored. Tonight, we open the door to those hidden studies, the ones that bent logic, challenged physics, and left behind data no one wants to explain. This is the hidden experiments that bent reality itself. The Philadelphia Experiment. In the middle of World War II, when the world was swallowed by fire and every nation searched for an advantage powerful enough to shift history, a quiet naval project emerged from the shadows. It would later become one of the most persistent legends in modern military lore. An experiment said not just to challenge the laws of physics, but to bend the edges of reality itself. It was known as the Philadelphia Experiment. According to the story, the United States Navy sought a breakthrough that would make its fleet untouchable. If a ship could be hidden from radar, it could move silently across the ocean, immune to detection, immune to threat. Officially, the research involved electromagnetic technology, an attempt to distort radio waves and hide vessels within controlled fields. But as the tale grew in whispered circles and declassified fragments, the goal seemed to grow far larger. Not merely invisibility to enemy instruments, but invisibility to the world itself. The vessel chosen was the USS Eldridge, docked quietly at the Philadelphia Naval Shipyard in 1943. Witnesses later described technicians adjusting coils of heavy cable, sealing equipment, and preparing generators that hummed with strange, pulsing energy. The atmosphere around the ship felt charged, as if the air itself was growing denser, waiting for something unusual. And then, as the story goes, the experiment began. Crew members stood at their stations as currents surged through massive conductors. A low vibration filled the metal hull, then rose into a deep, resonant hum. Eyewitnesses outside the ship spoke of a faint green mist forming around the vessel, a shimmering distortion rolling across its surface, as though the ship was dissolving into heat haze. Within seconds, the Eldridge faded, not into invisibility like a stealth aircraft, but into absence. Where steel and sailors once stood, there was only open water. The official record ends with a denial, but the unofficial version continues, whispered between veterans, conspiracists, and curious physicists. It claims that the Eldridge did not simply vanish from sight. It reportedly reappeared hundreds of miles away at the Norfolk Naval Yard, materializing briefly before blinking out once more. And then, just as suddenly as it had left, the ship returned to Philadelphia, as if reality snapped back into place around it. The event was not triumphant. It was described instead as chaos. Witnesses spoke of men stumbling, disoriented, unable to recognize surroundings or one another. Some were said to be violently ill, as though their bodies had experienced forces no human nervous system was meant to endure. Others, the darkest stories claim, had fused into bulkheads and decks, trapped halfway inside solid steel, as if their physical form had blurred and reassembled without guidance. A few sailors reportedly vanished completely, never accounted for again. And some, according to persistent rumor, reappeared later in strange places, confused, frightened, and speaking in fragmented sentences about fading in and out of sight. The psychological aftermath became another strange chapter. Sailors who supposedly survived described sudden aggression, memory gaps, and long periods of blank staring, as though they were silently listening to something no one else could hear. Reports circulated of men slipping out of normal time, appearing and disappearing briefly, then returning startled and shaken. These accounts, though unverifiable, fueled the sense that whatever happened aboard the Eldridge extended beyond technology and into the fabric of perception. Official explanations eventually surfaced, claiming the story was a misunderstanding of conventional naval research, specifically degaussing, a technique used to reduce magnetic signatures and protect ships from mines. But the legend refused to fade. It had already grown roots in the cultural imagination, supported by testimonies, letters, and the persistent belief that wartime desperation had opened a door into a field of science still not understood today. Modern interpretations vary. Some propose that the experiment was an early investigation into unified field theory, the long-pursued idea that electromagnetism and gravity might be linked. Others suggest accidental tampering with spacetime, a brief rift caused by uncontrolled electromagnetic fields. A more grounded perspective argues that the event never occurred and formed instead from disinformation, faulty memory, or psychological distress in a turbulent era. Yet none of these explanations fully erase the eerie consistency in how the tale is told. A consistency that persists despite decades of investigation, denial, and analysis. The Philadelphia experiment lives in that quiet place where forgotten research, wartime secrecy, and collective memory overlap. Perhaps nothing happened at all, and it is simply a story shaped by fear, imagination, and coincidence. Or perhaps, for one brief moment in 1943, a handful of engineers and sailors touched a boundary meant to remain untouched, and glimpsed what lies beyond the familiar borders of space, matter, and time. Today, it exists not only as a mystery of military history, but as a symbol of humanity's relentless drive to go further than wisdom allows. Whatever the truth, the legend endures, suspended between science and myth, like a ripple in the surface of reality that has never fully settled. The Montauk Project. On the far eastern edge of Long Island, where the land narrows into quiet dunes and the ocean stretches into endless horizon, sits an abandoned military installation known as Camp Hero. Today it is silent. Concrete bunkers peek from overgrown brush, rusted gates sag under coastal wind, and radar towers stand frozen in time, relics of another era. Yet, according to one of the most enduring legends of American secret research, this place was once more than a military station. It was a laboratory where the boundaries of thought, perception, and possibly reality itself were pushed to their breaking point. This is the story of the Montauk Project. The origins of the tale reach back to the Cold War, a time when rival nations sought not only technological dominance, but influence over the unseen realms of psychology, consciousness, and information. Rumors grew that, after certain intelligence programs were dismantled publicly, parts of them quietly continued in hidden facilities. Montauk, remote and surrounded by natural barriers, seemed the ideal place for experiments that could not exist in the light. Accounts describe a covert program housed beneath the surface, in chambers shielded from outside detection. According to testimony from alleged insiders, the research centered on amplification of the human mind, using electromagnetic fields, sensory manipulation, and advanced computation. Participants reportedly sat in sealed chairs surrounded by coils and machinery, their thoughts magnified and projected through equipment designed to translate mental images into physical phenomena. Some versions of the story detail experiments in controlled perception, where subjects were guided into deep altered states and prompted to visualize distant locations, moments, or events. Others speak of attempts to induce collective experiences, synchronizing minds across distances or layers of awareness. The tone of these accounts is clinical yet unnerving. Not mystical rituals, but engineered consciousness, performed with the same precision one would apply to radar systems or communications arrays. The most dramatic claims describe the creation of what participants called the Montauk chair, a device said to enhance psychic output and allow thoughts to imprint themselves into structured systems. Within these narratives, subjects reported visions that shifted from simple imagery to cascading impressions, as if the internal world was expanding beyond personal boundaries. Some stories mention thought forms, shapes or figures appearing briefly in controlled chambers, flickering like echoes from an unseen dimension. Whether the result of imagination, stress, or something stranger, these accounts give the program an almost dreamlike quality. As the legend evolved, it expanded into claims of time displacement experiments, attempts to open windows into other epochs or potential realities. According to supporters of the story, time was treated not as a strict line but as a field that could be bent, accessed, or influenced. Narratives tell of subjects returning from sessions disoriented, with impressions of places they had never visited and memories that did not align with their own timelines. Though impossible to verify, such details added a haunting layer to an already unsettling tale. Those who believe the Montauk Project was real often point to legitimate government research into psychology, electromagnetic fields, and remote perception conducted during the same historical period. The connection between declassified programs and the Montauk legend fuels the idea that what began in known laboratories may have continued in hidden environments after public scrutiny intensified. The presence of Cold War infrastructure beneath the site, sealed tunnels, buried rooms, and reinforced conduits, supports the sense of mystery, though none of it proves anything beyond military history. Skeptics argue that the story grew from fabricated testimony and the power of suggestion, fueled by fear of government secrecy and fascination with the unexplained. They point out that no confirmed documents tie Montauk to classified research, and that extraordinary claims require extraordinary evidence. Yet despite rational dismissal, the legend persists, carried by the compelling alignment of place, era, and the enduring human suspicion that what we see is only part of a larger truth. Today, Camp Hero is a park, calm and open to the wind, but the atmosphere still feels heavy with forgotten purpose. Visitors report strange sensations around sealed structures and the towering radar array, as though the air retains faint residue of something once active. Whether caused by imagination, abandoned machinery, or the psychological weight of layered stories, the environment encourages contemplation. What once happened here, and what boundaries might have been crossed in pursuit of power or knowledge. The Montauk Project remains one of America's most enigmatic tales. Too elaborate to dismiss entirely, too unsupported to confirm. It stands as a quiet marker between proven history and speculative memory, between documented research and whispered accounts of minds stretched beyond ordinary limits. If nothing happened, then it is a remarkable cultural myth born from secrecy and paranoia. If even a fraction is true, then somewhere beneath the quiet earth at Montauk, science may have brushed against forces and structures that shape thought, perception, and time itself. For now, the truth rests beneath concrete and sand, held in silence by a coastline that has watched decades pass. Like many stories born in the shadows of classified research, the Montauk Project endures as a reminder that humanity's greatest experiments often unfold where few are allowed to look, and where the edges of reality may be thinner than they appear. MKUltra. In the years following the Second World War, a silent conflict emerged, one fought not with tanks and artillery, but with information, perception, and the fragile architecture of the human mind. As rival nations searched for ways to influence global events without force, a new frontier opened: psychological control. From that atmosphere of tension and ambition came one of the most unsettling programs in American intelligence history. It would later be known simply as MKUltra. Officially launched in the early 1950s, the program sought to understand, and if possible direct, the deeper workings of consciousness. Analysts feared that foreign powers were developing techniques to manipulate thought, memory, and loyalty. In response, researchers attempted to master methods of mental influence before others could. It was not a project of ideology or philosophy, but of strategic necessity, at least in the eyes of those who designed it. The research unfolded across hospitals, universities, and private facilities. Much of it was disguised as clinical study or academic inquiry. Behind closed doors, however, techniques grew increasingly extreme. Psychoactive compounds were administered in controlled chambers. Participants were placed into sensory deprivation tanks, left suspended in silence and darkness for hours. In other sessions, bright lights, sound frequencies, and prolonged stress were used to fracture ordinary awareness. Some subjects volunteered, believing they were part of harmless psychological studies. Others never knew they had been chosen at all. One core goal was to erase identity, to break the continuity of memory and self, and then rebuild it according to new patterns. Chemicals capable of dissolving mental defenses were combined with suggestion and repetition. Patients awoke unsure of what had happened, or who they were before the experiments began. Some recovered and returned quietly to normal life. Others did not. The program stretched across years, gathering data not only on the limits of mental resilience, but on the fragile points where consciousness gives way to something unanchored and malleable. Records show that entire frameworks were constructed to explore the possibility of creating controlled personalities, conditioned responses, and altered motivations. Intelligence agencies were not pursuing mysticism. They were pursuing a tactical edge, a way to guide decisions without force, and perhaps even create agents unaware of their own programming. In this pursuit, ethics became secondary, overshadowed by the fear of falling behind foreign adversaries. The secrecy surrounding MKUltra was immense. Files were compartmentalized, operations cloaked in coded funding, and oversight kept minimal. When fragments of the program became public years later, it was not through official disclosure but through investigative persistence. Hearings were held, testimonies gathered, and a partial archive surfaced. Much of the program's documentation had already been destroyed under orders, leaving gaps where answers should have been. What remained painted a picture not of cinematic conspiracy, but of methodical experimentation carried out by educated minds convinced they were guarding national security. In time, the program was formally ended, and its existence acknowledged with cautious language and selective transparency. Officials framed it as a historical misjudgment born from an era of extreme geopolitical pressure. Yet the incomplete nature of the record has allowed speculation to thrive. Many believe that segments of the research continued under different names, concealed within advanced behavioral programs and neuropsychological studies. Others argue that the deepest work, the work that approached the edges of consciousness, never stopped at all, simply retreated further into obscurity. For those who look at MKUltra from a scientific perspective, it represents a moment when psychology shifted from theory to applied force. It demonstrated how profoundly the human mind could be disrupted, shaped, and reassembled through isolation, chemistry, and suggestion. It also exposed an uncomfortable truth, that understanding the mechanisms of thought offers not only insight, but control. To this day, the program remains a stark reminder of the ethical limits tested during moments of global uncertainty. Its legacy is not only historical, but conceptual. It exists at the intersection of verified fact and enduring unease, where official acknowledgement meets quiet speculation. Some view it as a cautionary tale. Others see it as evidence that the mind is a domain governments have long considered as valuable as land, technology, or weaponry. In the quiet space between known history and sealed archives, MKUltra endures. It is neither myth nor fully revealed truth, but a shadow cast across decades of research into memory, identity, and the invisible currents that steer human behavior. Whatever its full scope may have been, it stands as proof that the study of consciousness is not only a scientific pursuit, but a strategic one shaped by ambition and secrecy, and capable of reaching places the human mind was never meant to be pushed. Project Stargate. In the final decades of the 20th century, while technology advanced and satellites mapped the world in silent precision, a quieter and stranger pursuit unfolded deep within American intelligence circles. Unlike programs built on machines and mathematics, this one focused on a far more fragile instrument, the human mind. It would come to be known as Project Stargate, a long-running effort to determine whether perception could extend beyond the boundaries of sight, distance, and conventional physics. The origin of the program lay in a simple strategic concern, that foreign adversaries might be exploring unconventional methods of gathering intelligence. Reports suggested that experiments in extrasensory perception and remote awareness were being conducted overseas. Rather than dismissing the possibility, American agencies chose to investigate it themselves. Behind secure doors and under controlled protocols, they began to study whether thought alone could access information that physical senses could not. At the center of the program was a practice called remote viewing, the attempt to perceive distant locations, objects, or events through focused mental effort. Participants sat in quiet rooms, insulated from distraction, guided into calm concentration. They were given coordinates, photographs concealed in envelopes, or vague taskings with minimal context. Their role was not to guess, speculate, or imagine, but to allow impressions to surface, unforced and unfiltered. They recorded sketches, sensations, fragments of shape or texture, and descriptions of landscapes or structures they had never seen. Researchers documented these sessions with careful, methodical discipline. The goal was not belief but measurement. Data was compared, coded, and analyzed for patterns. Some results appeared inconclusive, shaped by suggestion and uncertainty. Others seemed startlingly aligned with real places and events, enough to draw continued funding and deeper investigation. For decades, the program moved between secrecy and semi-official acknowledgement, always existing one step outside conventional science, yet never fully dismissed by those who had witnessed its more precise moments. The individuals involved in remote viewing were not mystics or esoteric practitioners. Many were military personnel and trained analysts, selected for discipline, focus, and stability. Their work required patience, clarity, and the ability to maintain a calm internal state while allowing subtle impressions to form. Over time, they developed techniques to refine their attention, quiet internal dialogue, and translate fleeting perceptions into structured reports. The environment they worked in resembled not a ritual chamber, but a psychological laboratory. As the years passed, the program expanded, contracted, and shifted names under changing administrations and budgets. Files accumulated, containing transcripts, sketches, and assessments. Targets ranged from distant facilities to hidden objects, from foreign test sites to hostage situations. Some sessions produced results that seemed to defy explanation. Others yielded ambiguity, shaped by the inherent difficulty of measuring inner perception with outer metrics. Yet even the uncertain outcomes contributed to a growing archive of human attempts to perceive without sight. Eventually, the program was officially closed. Publicly, it was described as interesting but impractical, a curiosity that failed to produce consistent intelligence value. Reports were released, though often incomplete, leaving gaps where answers might have settled debate. For many, the closure represented the end of an unusual scientific chapter, a moment when government stepped briefly into the intangible world and then retreated back to technology and physical data. Yet the full legacy of Project Stargate remains complex. Those who participated often speak with measured reflection, describing not dramatic visions but subtle impressions, arriving unbidden yet difficult to ignore. They talk about sessions where scattered perceptions unexpectedly aligned with real-world details, and moments when the boundary between internal and external information seemed unexpectedly thin. Not triumphal stories, but quiet ones, marked by contemplation more than certainty. To observers, the program occupies a space between scientific possibility and human curiosity. Some view it as evidence that consciousness holds capabilities still unexplored, waiting for methodologies advanced enough to measure them. Others consider it a historical anomaly, born from geopolitical pressure and the desire to explore every potential strategic avenue, no matter how unconventional. Both perspectives recognize the seriousness with which the work was approached, and the discipline applied to phenomena that are often relegated to speculation. Today, Project Stargate rests in a strange place within public memory. Not dismissed as fantasy, not confirmed as breakthrough, but suspended in the delicate balance between documented history and unresolved potential. Its quiet rooms, focused minds, and carefully collected results form a reminder that the boundaries of human perception are not fully mapped, and that even institutions built on logic and security have, at times, looked toward the unknown with cautious curiosity. Whether the program revealed hidden aspects of awareness or simply tested the limits of expectation, it left behind something rare, a record of formal inquiry into the subtle depths of the mind. And in that record lies an enduring question, carried without urgency or drama. Not whether the extraordinary is real, but whether humanity has yet learned how to measure the subtle territories where thought reaches further than understanding. The Large Hadron Collider reality glitch, on the border between France and Switzerland, beneath gently rolling fields and quiet countryside, lies one of the most ambitious scientific instruments ever built, the Large Hadron Collider. A circular tunnel stretching nearly 27 kilometers, filled with superconducting magnets and sensors operating at temperatures colder than deep space. Here, particles are pushed to near-light speed and brought into collision, recreating energy's last seen moments after the birth of the universe. The official goal has always been clear: to understand the fundamental structure of matter and the forces that shape existence. Yet over time, a quieter narrative has grown beside the scientific one, suggesting that the collider did not merely probe reality, but may have brushed against its limits. In 2012, the discovery of the Higgs boson marked a milestone in physics, a confirmation of a field that gives mass to particles. It was a triumph of collective effort, precision engineering, and decades of theory. Public celebrations followed, Press conferences were held, and the scientific world felt a sense of clarity. But outside those circles, another reaction unfolded, subtle and uneasy. People began to speak of small dissonances, memories that did not align, cultural details that felt slightly altered, familiar events remembered differently than they appeared in documentation. Individually, the differences were minor. Together, they formed a ripple of uncertainty that became known informally as a reality glitch. This perception was not tied to the collider by its designers or operators. Instead, it emerged from the public imagination, shaped by the unusual timing. A historic manipulation of fundamental forces followed by a wave of shared, subtle doubt about lived memory. Conversations formed online and in private, quiet at first, then growing. Individuals reported recollections that diverged just enough from consensus to be unsettling. A book title, a historical detail, a line from a familiar film. None of it indicated malfunction or catastrophe. Instead, it resembled a shift too gentle to measure, yet too persistent to ignore. Physicists dismissed these claims as cognitive error, a natural product of imperfect memory and cultural suggestion. Researchers continued their work, exploring high-energy interactions, searching for dark matter signatures, and refining models of the early universe. Within the scientific community, the collider remained firmly grounded in evidence and data, guided by rigorous peer review. Yet the public perception of it slowly became layered, a place where cutting-edge research coexisted with a growing sense that something intangible had been disturbed. The idea gained momentum not through dramatic events, but through the quiet accumulation of experience. People described moments of sudden unfamiliarity, as if stepping into a world nearly identical to the one they knew, yet slightly misaligned. These impressions were rarely dramatic. They were subtle shifts, like a familiar object placed a few centimeters off from memory, or a familiar timeline containing a detail unexpectedly altered. For some, these sensations passed quickly. For others, they lingered. The legend that formed was not built on fear, but on the notion that reality might not be entirely fixed, that the universe could contain states delicate enough to be nudged under the right conditions. From a scientific standpoint, the collider represents the frontier of controlled energy and measurement, probing the smallest scales where matter and spacetime may follow unfamiliar rules. Theoretical frameworks occasionally entertain exotic possibilities, microscopic black holes, transient fluctuations, or mathematical structures that connect space differently at quantum scales. Yet these remain within speculative physics, not confirmed fact. The researchers involved operate with caution, grounded in repeatable evidence rather than imagination. Still, the mere existence of such capabilities has influenced public consciousness, feeding the quiet belief that humanity may be closer than ever to touching the deeper machinery of the universe. Over the years, the narrative has taken on a meditative quality rather than a dramatic one. The collider continues to function, producing data, refining theories, and expanding understanding. Life moves forward as it always has, and yet the glitch story persists, not as accusation or alarm, but as a modern myth shaped by the intersection of advanced science and human perception. It reflects the delicate boundary between observable reality and internal experience, where memory meets measurement and personal truth meets shared consensus. In this story, the Large Hadron Collider becomes more than machinery. It becomes a symbol of transition, a reminder that as knowledge deepens, the certainty of perception may soften. Whether the subtle unease arose from coincidence, collective psychology, or something more elusive, it has settled into the culture surrounding the collider. A quiet thread of speculation woven into the broader narrative of scientific progress. Today, the idea of a reality glitch remains neither proven nor disproven. It exists in the same space where unanswered questions have always lived, at the edge of understanding, guided by intuition and curiosity. And as the collider continues its work beneath calm European landscapes, it carries with it the dual legacy of modern physics: the pursuit of knowledge and the ever-present mystery that lies just beyond the limits of what can be measured. The Soviet Psychotronics program. During the Cold War, scientific ambition was shaped as much by secrecy as by innovation. Vast research networks stretched across continents, driven by a quiet competition to understand not only the physical world, but the hidden mechanisms of perception, influence, and thought itself. In the Soviet Union, one of the most enigmatic of these pursuits took place under a broad and mysterious term: psychotronics. It referred not to a single project, but to a constellation of studies, theories, and classified programs exploring the possibility that human consciousness could interact with the physical environment in ways science had not yet explained. Official archives describe it as a multidisciplinary effort involving biology, physics, psychology, and emerging theories of information transfer. The work was scattered across laboratories, military institutes, and academic facilities. Researchers investigated unusual neural responses, bioelectromagnetic fields, and subtle interactions between mind and environment. Some experiments examined the influence of directed attention or emotional states on physical systems. Others explored remote perception and nonverbal information transfer. To the outside world, much of this activity remained invisible, concealed behind technical language and restricted access. While the United States invested heavily in programs like MKUltra and Project Stargate, Soviet thinkers developed their own framework, blending strict scientific method with elements of theoretical physics and human physiology. Documents referenced bioinformation fields, neural energy transmission, and extrasensory communication, not as mysticism but as unexplored branches of natural science. In internal reports, research was presented calmly, methodically, and without sensationalism. The intention was not to entertain speculation, but to map unknown terrain. Among the themes present in these efforts was the idea that consciousness might not be confined entirely to neural tissue. Some theorists proposed that thoughts could generate subtle, measurable effects in physical systems, particularly electromagnetic environments. Others examined whether certain individuals possessed heightened sensitivity to remote stimuli or unusual cognitive resilience under stress. The language used was clinical, even dry, yet it hinted at a deeper ambition: to understand the latent capacities of the mind in a structured, disciplined way. Facilities associated with psychotronic research conducted experiments on reaction time, sensory adaptation, cognitive load, and physiological responses to controlled stimuli. There are references to shielded rooms, precise monitoring equipment, and long-form testing procedures. In some cases, participants practiced extended concentration, attempting to alter the behavior of simple mechanical devices or biological cultures. Reports describe results that were inconclusive, subtle, or sporadic, yet persistent enough to justify continued investigation. To outside observers, these activities later took on a mythic quality. Rumors spoke of psychic soldiers, mind-based weaponry, and energy-influenced technologies. However, the surviving documentation paints a quieter picture, one of long hours, careful measurement, and a sense that researchers stood at the threshold of something they could not fully define. The tone was not dramatic. It was contemplative, grounded in the belief that human cognition might hold properties not yet fully described by physics or neurobiology. The collapse of the Soviet Union brought disruption. Funding shifted, institutes dissolved, and many projects faded into obscurity. Equipment was dismantled or repurposed, and archives became fragmented. Some researchers emigrated, carrying ideas and unpublished data with them. Others transitioned into civilian neuroscience, continuing to explore cognition through more conventional means. The psychotronic legacy did not disappear. It simply dispersed, dissolving into broader scientific and cultural memory. Today, the story of Soviet psychotronics sits in a space between documented history and unresolved curiosity. Portions are archived, pieces remain classified, and other fragments survive only in personal recollection and scattered research notes. There is no definitive conclusion, no announcement of breakthrough or closure. Instead, there is a quiet residue, a sense of unfinished inquiry, as if the field paused rather than ended. What remains most striking is not speculation, but the atmosphere surrounding the work. It reflects an era when governments and scientists, faced with vast unknowns, pursued even the faintest possibility that reality might contain hidden channels of interaction. It reflects a willingness to explore the boundary where psychology meets physics, where thought meets measurement, where the observable world brushes against the subjective one. Whether the results reached beyond conventional science or simply broadened the study of human perception, They formed part of a larger effort to understand the brain not only as a biological organ, but as a dynamic participant in the physical environment. In historical perspective, the Soviet Psychotronics program represents a moment when the scientific imagination extended into territory without clear maps. It embodies the tension between rigorous inquiry and the impulse to search where evidence is still sparse. And though the work now exists mostly in fragments, it stands as a reminder of a time when nations looked toward the mind with the same intensity they directed at the atom, convinced that the next frontier of power and understanding might lie within human consciousness itself. Project Blue Beam. In the late 20th century, as technology advanced and global communication tightened, a theory emerged that suggested science and perception could be shaped not only by discovery, but by design. It centered on a concept known today as Project Blue Beam. According to the narrative, it was not a military initiative in the conventional sense, nor a scientific program officially acknowledged by any institution. Instead, it lived in a space between rumor and classified speculation, describing a hypothetical effort to influence collective reality through the deliberate use of advanced imaging, psychological manipulation, and staged phenomena. The idea gained attention through fragmented references, quiet discussions, and scattered reports that spoke of a planned evolution of information control. Rather than influencing individuals through direct means, it proposed that entire populations could be guided through immersive optical technology, electromagnetic systems, and precision media techniques. In this telling, the human mind became a receptive system, responsive not only to belief and suggestion, but to coordinated narratives carried by light, sound, and digital simulation. Descriptions of Blue Beam suggested an architecture built on 4 conceptual stages. First, the alteration of historical understanding, not by erasing records, but by introducing doubt and manufactured alternatives until the line between fact and interpretation softened. Second, the projection of large-scale visual phenomena, using satellite systems and directed imaging to display structured illusions within the sky. Third, the simulation of communication and internal experience through targeted frequency manipulation. Fourth, the orchestration of a unifying psychological event designed to consolidate authority through awe rather than force. These ideas were never presented in technical manuals or scientific journals. They appeared instead in scattered publications, interviews, and speculative research tied loosely to intelligence developments and emerging media technologies. Supporters pointed to steady advances in digital simulation, holography, atmospheric projection, and neural influence research as quiet evidence. Skeptics saw the concept as a metaphor, a commentary on power, information, and the subtle mechanisms through which belief can be shaped without physical coercion. The myth grew not from proof, but from timing. As computer-generated imagery became increasingly realistic, as media ecosystems evolved into real-time global networks, and as satellites began to cover every inhabited region of Earth, Blue Beam shifted from fringe speculation to a cultural reference point. It transformed into a symbolic narrative about the interface between technology and perception. The theory suggested that reality could become pliable not only through physics or biology, but through precisely engineered experience. Over time, the story became less about a specific plan and more about a principle. That belief can be guided by coordinated stimuli, and that the tools for such influence grow more refined with each decade. In this way, Project Blue Beam occupies a conceptual territory similar to earlier psychological operations and communication strategies, but framed on a planetary scale. It speaks to the evolving relationship between vision and trust, where the line between authentic observation and artificial projection becomes increasingly delicate. From a technological standpoint, the components described were not impossible. Atmospheric projection experiments have been conducted for entertainment and meteorological visualization. Directed audio systems can focus sound like a beam. Neural modulation research explores subtle ways to influence perception through electromagnetic fields. None of these technologies imply the existence of Blue Beam as an organized initiative. Yet taken together, they form an ecosystem in which the core premise, shaping subjective reality through engineered stimuli, feels less like fiction and more like an eventual capability. The endurance of Project Blue Beam as a cultural phenomenon lies in its tone. It is rarely framed with alarm. Instead, it is observed with quiet curiosity. It reflects a world in which images, information, and emotion flow continuously, shaped by invisible infrastructure and unseen algorithms. It treats the sky not as a fixed backdrop, but as a potential canvas. It treats perception as a channel through which influence can move silently, without visible edges. Whether or not such a program ever existed is secondary to the concept it represents. Blue beam functions as a metaphor for the age of mediated reality, an era in which the boundary between experience and manufacture becomes fluid, in which belief can be engineered with precision, and in which technology enters the most personal territory, the interpretation of the world itself. It stands as a reminder that power does not always operate through force or decree. Sometimes it works through light, pattern, and the quiet calibration of perception. Today, discussions of Project Blue Beam continue in academic circles, online forums, and speculative research, not as evidence-based history but as a thought experiment about the future of influence. It rests at the intersection of psychology, optics, and digital culture. And like many modern myths, it lingers because it speaks to an unspoken truth, that as tools evolve and communication becomes seamless, the most profound experiments may not test the limits of matter, but the boundaries of shared reality. The Philadelphia Time Slip Soldiers. Among the quieter strands connected to the Philadelphia experiment is a story not about invisibility or magnetic fields alone, but about displacement not simply in space but in time. It does not come from official papers or public testimony, but from fragments of accounts that suggest a second layer to the event. These stories speak of servicemen who did not merely disappear from sight, but slipped from the continuity of ordinary reality, becoming unanchored from the moment in which they lived. They came to be known as the Philadelphia Time Slip Soldiers. According to the narrative, when the USS Eldridge participated in the naval experiment in 1943, the intended objective was to obscure the vessel from enemy detection. What followed in this telling extended beyond expectation. The ship reportedly shimmered, then vanished from visual perception for a period of time, surrounded by a field of electromagnetic energy. What happened within that field became a focal point of speculation. Witnesses later described disorientation, distortion, and a profound sense of disconnection, as if the boundaries between time and space had momentarily softened. The most striking claims came from individuals who suggested that several crew members did not return in the same condition in which they had left. Some accounts describe soldiers appearing days later in unexpected locations, seemingly confused, unable to account for lost time. Others speak of men who reported strange intervals of absence, moments when they were aware, yet unstuck from their surroundings, observing scenes that felt familiar yet displaced, as though they had stepped outside the linear flow of events. In these descriptions, time becomes a fluid medium rather than a fixed sequence. The individuals affected were said to experience sudden shifts, brief flashes of distant moments, perceptions of environments that did not match their immediate context, and sensations of standing both within and outside their own bodies. The language used by those recounting these claims was not dramatic, but unsettled, shaped by the difficulty of describing a state where the familiar rules of cause and effect felt interrupted. Some versions of the story include accounts of individuals who reportedly struggled to remain anchored to the present after the experiment ended. They spoke of drifting sensations, disappearing briefly from sight, or becoming momentarily intangible, as if caught between phases. These descriptions were not supported by official records, yet they persisted in discussion among sailors, researchers, and those intrigued by the intersection of physics and human experience. In these stories, the affected servicemen were not treated as anomalies, but as unintentional participants in a moment when military ambition collided with the unknown structure of reality. Theories that emerged later attempted to frame these events in scientific language. Proposals mentioned electromagnetic fields interacting with spacetime, quantum discontinuities, and disturbances in temporal coherence. Some suggested that intense field exposure might have caused neural misalignment or perceptual echoes. Others described the possibility of localized time dilation effects, not as science fiction, but as inadvertent consequences of experimenting at scales where established physical models begin to blur. Yet there were no authoritative explanations, no consensus, and no official recognition. Reports surfaced quietly, carried by word of mouth and selective testimony rather than institutional release. Those who spoke of these events did so with care, not aiming to convince, but to express a lingering memory of a moment that felt too unusual to dismiss. Over time, these accounts formed a subdued narrative, not a dramatic legend, but a contemplative record of dislocation and return. The Philadelphia Times slip soldiers, as they came to be called in whispered retellings, became symbols not of disappearance, but of displacement. Their story reflects a fear and fascination shared across eras. The idea that time may not be as rigid as experience suggests, and that certain forces might brush against its threads without warning. Whether taken literally, metaphorically, or psychologically, their tale sits at the edge of thought, where the known touches a boundary, and the boundary briefly opens. Today, the narrative continues quietly, absent of spectacle or urgency. It does not claim resolution or assert definitive truth. Instead, it lingers as part of the broader mystery surrounding wartime research and experimental physics. It offers a reminder that some stories persist not because they are proven, but because they speak to the possibility that reality may have layers still unmeasured, and that in rare moments, individuals may find themselves passing through the spaces between them. Russian quantum teleportation claims. In the closing years of the Soviet Union and the decades that followed, Russia maintained a long-standing interest in the frontier where theoretical physics meets emerging technology. Among the stories that surfaced from this period was a quiet set of claims surrounding experiments loosely described as quantum teleportation. They did not refer to dramatic disappearance of objects, nor the cinematic transport of matter from one place to another. Instead, they suggested that research teams pursued ways to transmit information and physical states through mechanisms that bypass traditional pathways, exploring non-classical fields of interaction. References to this work rarely appeared in formal publications. Instead, they emerged from conference notes, interviews with researchers, and internal academic communications. Scientists associated with these efforts spoke calmly, using technical language shaped by quantum mechanics and information theory. They discussed entanglement, phase coherence, and nonlinear field coupling, framing teleportation not as transport of physical bodies, but as the precise transfer of state information across controlled environments. According to these accounts, small-scale laboratory setups used paired particles and specialized detection arrays. Researchers attempted to manipulate one system while observing correlated reactions in another, not through classical communication, but through quantum connection. Early experiments reportedly involved photons and microwave signals. Later efforts explored behavior in low-temperature materials and controlled electromagnetic chambers. The results, as described, were subtle: transient correlations, rapid signal alignment events, and anomalous synchronization between separated instruments. Nothing definitive, yet enough to sustain further inquiry. Some versions of the story suggest that during a particular test sequence, researchers noted a momentary event in which an encoded signal appeared to shift from one apparatus to another without measurable transit. The shift was brief, difficult to replicate, and sensitive to environmental noise. No mass moved, no object vanished or reformed. Instead, a configuration changed, a state seemed to imprint itself elsewhere. To outside observers, such a phenomenon would appear modest. Yet within quantum theory, even such a moment would signify a pathway beyond classical transmission, hinting at methods of information transfer not dependent on physical carriers. These claims remained largely unpublicized. Russia's scientific community has historically approached unconventional results with caution, preferring to refine data quietly rather than announce premature conclusions. Funding for advanced research fluctuated during the nation's transition period, causing projects to fragment or disperse. Equipment was relocated, laboratories reorganized, and researchers followed different paths, some continuing academic work, others entering private technology or international collaborations. The thread of quantum teleportation research did not vanish. It became diffuse, fragmented across institutions and time. In later years, as quantum computing and entanglement experiments advanced globally, brief references resurfaced. Interviews with former participants hinted at experiments that were ahead of their era, conducted before reliable computational support or stable low-temperature systems were widely available. They described long nights of calibration, iterative testing, and faint signals appearing at the edge of measurement capability. No grand declarations, only a quiet suggestion that reality might allow shortcuts in information exchange under precise conditions. Outside scientific circles, these accounts took on a more speculative tone. Some observers connected them to strategic programs and intelligence applications. Others framed them as early steps toward communication systems immune to interception, or toward technologies that could one day influence remote environments without transmission delay. In public discussion, the phrase quantum teleportation acquired a symbolic quality, representing not an achieved breakthrough, but a theoretical possibility explored in laboratory secrecy during a complex era. From a modern perspective, the story reflects a moment when theory and ambition intersected in a nation undergoing profound change. It illustrates a pursuit not of dramatic spectacle, but of delicate interactions hidden beneath the threshold of ordinary measurement. It mirrors similar efforts elsewhere in the world, where physicists tested entanglement and coherence long before such concepts entered popular conversation. As global research now moves toward practical quantum communication and distributed computing, these early claims appear less speculative and more like markers on a long path toward a difficult frontier. Today, there is no definitive record confirming the full extent of these experiments. Their legacy survives in quiet statements, technical hints, and the restrained tone of scientists who worked at the boundary between known physics and emerging theory. The idea remains grounded not in fiction, but in the belief that information and matter may be connected in ways not yet fully mapped, and that under precise, controlled conditions, the universe may allow phenomena that feel momentarily untethered from conventional space and time. In this sense, the Russian quantum teleportation claims stand as part of a larger arc in scientific exploration, a period when researchers pushed into domains where certainty fades, and where the rules of familiar reality soften into possibility. They represent not a completed achievement, but an unresolved chapter, one that continues to echo as modern physics advances, gradually illuminating a realm that once existed only at the edge of theory and quiet confidence. DARPA parallel reality programs. Within the United States defense research ecosystem, DARPA has long stood at the threshold between established science and speculative horizon studies. Formed during the early Cold War to prevent technological surprise, the agency has pursued fields ranging from advanced computation to neurological engineering. Among the quieter threads to surface in technical conversations and scattered research abstracts is a concept often referred to as parallel reality programs, a collection of exploratory efforts investigating the possibility that reality may not be singular, and that human perception, physics, and computation might one day intersect in spaces previously considered theoretical. These efforts did not present themselves as dramatic attempts to open gateways or access alternate dimensions. Instead, they appeared as incremental, layered explorations of multi-state simulation, quantum information behavior, and neural environment interaction models. The language in accessible sources was restrained, composed of terms such as synthetic perceptual frameworks, multimodal cognitive mapping, and nonlinear environment modeling. Each phrase hinted at the idea that reality, as experienced, could be influenced or reconstructed through precise manipulation of sensory channels and computational architecture. Some programs focused on high-fidelity simulation environments capable of generating situations indistinguishable from physical space for training and analysis. These environments blended neural feedback loops, adaptive rendering algorithms, and cognitive load calibration. The stated purpose was to prepare individuals for complex real-world scenarios by immersing them in controlled alternate conditions. In practice, these experiments suggested that a sufficiently detailed simulation could shift not only perception, but physiological response, altering stress levels, decision patterns, and sensory assimilation as though the subject had temporarily stepped into a different world. Other research streams examined quantum state behavior, particularly the idea that information could occupy superpositional frameworks, enabling parallel computational tracks that briefly mirrored the structure of theoretical multiverse models. In these investigations, engineers and physicists explored whether advanced processors could evaluate divergent possibilities simultaneously, treating reality not as fixed, but as a spectrum of probabilistic trajectories. While the primary applications referenced secure communication and rapid decision modeling, the underlying implication remained: that computation might one day map structures analogous to parallel states of existence. A third area quietly tied to this theme involved neural pattern modulation. Experiments sought to understand how the brain constructs its sense of continuity, presence, and linear time. Researchers monitored individuals undergoing controlled sensory adjustments, electromagnetic stimulation, and cognitive immersion environments. The results were described as subtle shifts in temporal perception, spatial interpretation, and memory coherence. Participants reported moments of expanded awareness, brief distortions of sequence, or an altered sense of internal positioning, experiences that echoed, in muted form, the concept of stepping momentarily into an adjacent mode of reality. None of these programs framed their goals in speculative terms. There were no official declarations of dimension research, no open claims of alternate world access. Instead, the work sat at the intersection of defense, neuroscience, and theoretical computation, an effort to prepare for environments where physical and synthetic realities converge, where future conflicts and communication may occur across multi-layered cognitive and digital planes. Yet, as these components accumulated, observers outside the official sphere began to view them through a broader lens, interpreting the technologies as early frameworks for navigating parallel experiential fields. Over time, these scattered pieces formed a quiet narrative. Advanced simulation environments approached perceptual indistinguishability from the physical world. Quantum systems began to explore simultaneous state representation, edging toward architectures capable of modeling branching outcomes. Neural research probed the fragile boundaries of human perception, revealing how easily the mind can inhabit constructed experience when sensory cues are aligned. Each domain, pursued independently, hinted at a collective direction: the exploration of layered realities, whether engineered or inherent. Public documentation remains limited, and most information exists as technical fragments or speculative interpretation. Still, the tone surrounding these efforts has remained calm and methodical. There is no claim of breakthroughs beyond physics, nor evidence of dramatic experiments. Instead, the programs sit as stepping stones toward a future where reality may not be binary, where the line between physical and synthetic, between internal perception and external environment, becomes fluid. Today, the concept of DARPA parallel reality programs carries a quiet resonance. It symbolizes an era in which scientific inquiry moves beyond the physical frontier into the architecture of experience itself. It reflects a world preparing for environments where reality can be layered, where perception can be engineered with precision, and where the boundaries of what is real may depend not solely on matter, but on information, cognition, and coherence. These efforts do not assert that multiple realities have been reached or observed. Instead, they explore the frameworks that might someday allow humanity to understand or construct them, not through force but through deep knowledge of perception, physics, and the malleable nature of experience. They remain part of a broader trajectory, one that edges toward a quiet, profound question: whether reality is a singular plane or a spectrum that science is only beginning to trace. The Utah Skinwalker Research Program. In the remote basin of northeastern Utah, surrounded by quiet desert scrub and distant mountain silhouettes, lies a stretch of land that has been the subject of scientific curiosity and quiet government interest for decades. Known publicly as Skinwalker Ranch, it became a focal point for a formal research effort into unexplained aerial, electromagnetic, and biological phenomena. What began as local reports of unusual lights, strange animal behavior, and unexplained disturbances eventually led to structured investigation, funded privately at first and later supported through government channels. Over time, the ranch evolved from folklore landmark into a controlled observation environment, not for myth but for anomalous data. The program did not frame its mission in sensational terms. Instead, researchers approached the site as a natural laboratory where unusual environmental events could be monitored and cataloged. They constructed sensor networks, established recording stations, and documented atmospheric fluctuations, radiation patterns, and electromagnetic anomalies. The tone was methodical. Long hours spent tracking subtle signals, reviewing night vision footage, analyzing biological tissue samples, and measuring changes in the ground and surrounding air. The objective was not to confirm legends, but to determine whether the reports reflected measurable, repeatable phenomena. Accounts from those involved describe incidents that defied conventional classification. Instruments occasionally recorded sudden spikes in radiation in localized pockets of space, followed by immediate normalization. Cameras captured motion in empty air where no figure could be seen, while animals reacted as though something tangible were present. Livestock injuries appeared without signs of struggle or predator activity, accompanied by a silence that seemed to settle over the land in the moments preceding discovery. These events were documented without dramatic language, presented simply as anomalies resistant to straightforward explanation. Researchers also reported shifts in electronic equipment behavior when entering specific zones on the property. GPS systems lost coherence, radios crackled with unusual interference, and drones experienced unexpected navigational irregularities. Some personnel described brief sensations of disorientation, as if stepping into slightly altered spatial environments, while others noted momentary changes in auditory perception. Data logs revealed patterns that emerged in pulses rather than continuous streams, sudden events that began as quickly as they ended, leaving only incomplete traces. In addition to electromagnetic monitoring, biological studies were conducted. Local wildlife exhibited periods of heightened alertness, while domestic animals occasionally refused to approach certain areas. Behavioral shifts appeared without obvious trigger, sometimes aligned with environmental fluctuations captured by sensors. Investigators collected soil, water, and atmospheric samples, yet chemical analysis offered no clear cause. The program adopted a posture of careful observation rather than conclusion, acknowledging that the data did not conform neatly to known scientific frameworks. Throughout its duration, the research remained largely shielded from the public view. Reports were circulated within a limited sphere, written in measured technical language. They avoided speculative interpretation, focusing instead on cataloging events as they occurred. When unusual shapes appeared in the sky, they were recorded as aerial anomalies rather than identified craft. When sudden bursts of electromagnetic activity emerged, they were noted as transient spikes without attached theory. The goal was to maintain clarity, to document without imposing narrative on the unexplained. Eventually, government involvement became known through declassified materials, revealing that this site formed part of a broader effort to evaluate unidentified aerial and environmental phenomena. The program transitioned through phases, shifted leadership, and adapted its methodology as technology evolved. Equipment became more sophisticated, data processing more structured, and the scope widened to include correlations with observations in other regions. Through each phase, Skinwalker Ranch remained a persistent node, a location where measurements consistently pushed against the boundaries of conventional explanation. The Utah Skinwalker Research Program stands today not as proof of extraordinary forces, but as a record of disciplined curiosity applied to an environment rich with anomalies. It reflects an approach that does not rush towards supernatural conclusion, but neither dismisses data that resists simplification. The research demonstrated that certain locations may contain layered interactions, geological, electromagnetic, biological, and perceptual, that challenge current understanding. It presented a model for studying such places not with mythic framing, but with instrumentation, repetition, and patience. In the broader context of scientific inquiry, this program occupies a quiet and unusual space. It bridges folklore and defense research, rural landscape and advanced instrumentation, subjective report and objective measurement. It suggests that some environments may operate at the margins of known physics or perception, and that careful observation can reveal patterns even when causes remain unclear. Rather than claiming breakthrough or discovery, the program leaves behind steady, cumulative evidence of a world that may contain rare pockets where the ordinary rules of experience bend slightly, inviting continued study. The PEAR Lab Experiments. At Princeton University, far from military laboratories and remote government facilities, a quiet research effort unfolded over nearly 3 decades. Known as the PEAR Lab, the Princeton Engineering Anomalies Research Program, it operated at the intersection of psychology, physics, and human intention. Its purpose was not to explore mythology or folklore, but to examine whether the human mind could influence physical systems in measurable ways. Through thousands of controlled trials, Researchers studied the subtle boundary where consciousness and matter might interact, seeking patterns not accounted for by classical models. The laboratory focused on random event generators, devices engineered to produce sequences of numbers or binary states with complete unpredictability. Participants sat before these machines and attempted to influence their output through directed intention, concentration, or calm expectation. The protocols were structured, repeatable, and statistically monitored. Data was collected not in isolated bursts, but across years, forming one of the most extensive archives of its kind. The results, when analyzed, revealed deviations that were small in magnitude yet consistent enough to attract sustained academic interest. Researchers observed that certain individuals appeared more likely to produce statistically significant departures from randomness, while others showed no effect. The deviations did not resemble dramatic shifts or immediate control. Instead, they emerged as gentle biases, a subtle tendency for outcomes to lean in a preferred direction over long intervals. In many sessions, the influence was not constant but appeared in clustered intervals, suggesting that intention might operate through mechanisms unlike any classical force. The lab's scientists reported these findings in cautious language, emphasizing the need for careful interpretation rather than definitive claims. Another branch of research explored remote perception, the possibility that individuals could describe distant locations or hidden images without sensory access. Participants received coordinates or coded prompts, then provided impressions of unseen environments. Evaluators compared these descriptions against actual locations or target images using structured scoring systems. As with the random event studies, results showed patterns that deviated from chance in ways that could not be easily dismissed. The findings did not point to clear mechanisms, only to persistent anomalies that challenged conventional assumptions about perception and information transfer. Throughout its existence, the PEAR Lab operated with a spirit of academic rigor. Experiments were documented, statistical methods refined, and protocols adjusted to reduce bias. The atmosphere was meditative rather than sensational, a long-term attempt to understand whether consciousness might exert influence beyond the boundaries defined by established science. Critics raised concerns about methodology and interpretation, while supporters pointed to the consistency and volume of data as evidence that something unusual was occurring at the threshold of measurable reality. The program's director, an aerospace engineer, emphasized that the work did not seek to prove supernatural ability, but to test whether the mind might interact with probability fields under controlled conditions. The language used to describe results remained restrained, often focusing on the challenge of fitting non-traditional data into traditional scientific frameworks. Over time, the lab accumulated tens of millions of data points, forming a body of evidence that resisted easy dismissal yet avoided dramatic conclusion. When the laboratory eventually closed, its archives and equipment were preserved, and researchers continued to analyze data through independent foundations. The legacy of PEAR did not fade into obscurity. Instead, it became a reference point for modern studies in consciousness, information theory, and non-locality. The results continue to appear in academic discussions about the nature of randomness, statistical anomalies, and the possibility that thought may operate through channels not yet fully mapped by physics. Today, the PEAR Lab experiments stand as one of the longest and most structured attempts to examine mind-matter interaction with scientific discipline. They do not offer certainties, nor do they claim that consciousness reshapes physical laws. Instead, they reveal a region of inquiry where effects are faint, cumulative, and measured only through patience and repetition. Their contribution lies in the steady suggestion that human intention may leave subtle traces in the physical world, not through force, but through alignment, coherence, and the quiet persistence of directed thought. In this way, the PEAR program exemplifies a form of experimental mindfulness, a recognition that reality might contain delicate layers responsive to awareness, detectable only when noise is observed with enough care. It remains a chapter in modern research that does not resolve mystery, but preserves it, an archive of data, gathered slowly, hinting that the mind and the world may be connected through mechanisms still waiting to be fully understood. The Hutchison Effect. In a modest apartment laboratory in Vancouver during the late 1970s and 1980s, An independent researcher named John Hutchison conducted a series of experiments that would later become a point of fascination and debate within fringe science circles. His workspace did not resemble a polished institution, but rather a dense assembly of Tesla coils, high-voltage generators, radio frequency equipment, and pieces of metal suspended on makeshift stands. It was within this cluttered environment that unusual behaviors of matter were claimed to occur, effects that seemed to challenge accepted physics. Reports from these experiments describe metals bending without applied mechanical force, objects lifting from the ground, and materials fusing in ways inconsistent with heat-based welding. In some documented instances, pieces of metal appeared to soften and curl as though animated by an unseen field, while wooden objects embedded themselves into solid steel as if the boundary between materials momentarily lost rigidity. Hutchison did not assert a singular mechanism. Instead, he attributed these events to complex electromagnetic interactions created when his equipment operated in certain overlapping frequencies. Observers who visited the lab recounted witnessing objects vibrate, rise, or fall apart under no visible external pressure. Video footage, grainy and unpolished, captured debris trembling and bolts lifting from surfaces. Some items accelerated abruptly, while others floated gently before settling again. There were moments where metal fragments fractured with unusual patterns, as though internal structure had been disrupted without conventional stress. These occurrences, when they happened, emerged irregularly, appearing unpredictably and sometimes repeating, sometimes not, depending on the alignment of equipment and atmospheric conditions. Attempts to replicate the results in controlled settings proved difficult. Engineers and scientists examined the claims, yet reproducing the events reliably remained elusive. When researchers attempted to duplicate the laboratory's environment, the complexity of overlapping electromagnetic fields and the improvised configuration of devices posed challenges. Hutchison himself often emphasized that his results depended on subtle electrical dynamics rather than singular adjustable variables. His descriptions suggested that the effect was not a controlled force, but a phenomenon emerging from chaotic electrical interactions, a byproduct of unpredictable resonance between fields. Despite skepticism, samples attributed to the experiments circulated among independent analysts. Certain metal pieces displayed grain distortions and fused layers not easily explained through conventional machining or welding. Some researchers suggested that exposure to electromagnetic stress could alter material structure in rare circumstances, while others argued that the results should be examined through the lens of experimental anomaly rather than outright dismissal. Throughout the discourse, Hutchison maintained a calm, observational tone, presenting his findings not as definitive breakthroughs, but as recorded occurrences worthy of further study. Interest from defense and aerospace communities emerged quietly, with reports indicating that materials and footage were reviewed by specialists considering unconventional propulsion or field effect research. No official conclusions were released, leaving interpretation open. Hutchison's experiments existed in a space between amateur innovation and scientific curiosity, a reminder that occasionally unexpected observations arise outside formal institutions. The research did not transition into mainstream physics, yet it did not disappear into obscurity either. Instead, it remained a reference point in discussions about field interactions and anomalous matter behavior. As time passed, the narrative around the Hutchison effect shifted from direct demonstration to historical anomaly. The original laboratory setup was dismantled, equipment dispersed, and the era of spontaneous experiments faded into memory. Still, the recorded footage and scattered artifacts continued to circulate within certain scientific and engineering communities, occasionally resurfacing as a subject of quiet review. The effect, whether misunderstood phenomenon or unrepeatable glitch in experimental conditions, became part of a broader conversation about the limits of replication and the possibility that rare environmental factors may temporarily allow matter to behave outside typical boundaries. Today, the Hutchison effect endures as a case study in fringe physics, a record not of verified breakthroughs, but of anomalous results observed under unconventional conditions. It underscores the idea that not all interesting data arises within structured labs, and not all unexplained behavior can be dismissed solely because it is difficult to repeat. The story invites reflection on the nature of scientific discovery, where the boundary between anomaly and breakthrough is often thin and dependent on the tools and understanding available at the time. Quiet, unresolved, and suspended between skepticism and curiosity, the Hutchison Effect remains a chapter in experimental history defined not by certainty, but by the persistent suggestion that matter may, under rare and uncharted circumstances, respond to fields in ways that defy familiar models. It stands as a reminder that even in humble surroundings, the edges of physical reality can occasionally appear to ripple, offering brief glimpses into possibilities not yet fully mapped by science. Ending. If you've stayed with us through these remarkable accounts and quiet corners of scientific curiosity, thank you. Our world is wider than the borders of what we currently understand, and every question brings us one step closer to clarity. If this journey resonated with you, consider supporting the channel, a like, a subscription, a comment. Share this video with someone who wonders about the unseen layers of reality the same way you do. Your support helps us continue exploring, one mystery at a time. Until next time, stay curious and stay open to the unknown.